Hello and welcome to video 6. Today we will be talking about mass, and we will also be talking about slopes. And then also pulley systems, which are very crucial to physics. So pulleys usually just drawn as this, and then with a string going around like that, or any way. However, mostly in physics, we assume that the pulley is frictionless to simplify the problem. So we'll be assuming that for the problem that we're going to do later in the video, and also just use that when solving other problems involving pulleys. Now, slopes. Objects usually move down, right? And usually we have friction. So if you had an object here, usually there would be a force in this direction, which would be friction. However, this force or this factor can be ignored unless it is said so in the problem. So usually, if they don't want you to ignore friction, they'll give you a friction coefficient to solve the problem with. In this case, the problem we're going to do later in the video, we don't have to worry about that. Now, lastly, what we really want to do is kind of, when we start off with a problem like this, we want to draw out the free body diagrams. So this is mass 1, this is mass 2. So the problem here says both mass m and mass 1 and mass 2 are connected by a string that goes over a frictionless pulley, and then also the string. So the string, you can ignore the mass of the string, and the problem says that the block is accelerating down the incline. So if we had something like where there's only a pulley, where there's a mass here and a mass here, and it is moving down this way, then we would know that this mass is greater than this mass. So here we see something similar. However, this is, since it's a plane, we would have to take into consideration, since it's an angle, at an angle, we would have to take into consideration that angle. So here we go. The first option is that mass 2 is greater than mass 1, which doesn't make sense as it is moving that way, meaning mass 1 has to be heavier. The second option is mass 1 equals mass 2. Also doesn't really work, because otherwise they'd be sitting and there'd be no movement. Then the second option is mass 2 mass 2 times sine of 30 is greater than mass 1. However, that doesn't make sense, as mass 2 is the one moving up and down, while mass 1 is moving along the slope. So that leaves us with mass 1 times sine 30 is less than mass 2. However, this doesn't make sense, as mass 1 would have to be greater, along with the sine 30, to move it in that direction. So that leaves us with E, where mass 1 times sine of 30 degrees is greater than m2.